Okay, so the next topic is inserting irrational numbers between two rational and two irrational numbers, and also comparing irrational numbers. So let us take one example here. So the question is, we have to insert a rational and an irrational number between 3 and 4. Okay, so two rational numbers are 3 and 4. We have to insert a rational number. So we know that a rational number between 3 and 4 will be what? Will be 3 plus 4 by 2. That is 7 by 2. That is 3.5. Now this is easier method to find rational number between two whole numbers. If the rational numbers are in the form of p by q fractions, then you can use the method which we have discussed earlier. Okay, now let us find an irrational number. An irrational number between 3 and 4. Okay, so irrational number between 3 and 4. Let's write 3 here, 4 here. Can I write 3 as root 9? Yes. Can I write 4 as root 16? Yes. So now we have to find just one number between root 9 and root 16 which is not a perfect square. So root 10, root 11, root 12, root 13, root 14, root 15. We have so many options. They are all irrationals. You can write root 11 or 12 or root 12 or root 13, anything. So root 11 is one irrational number between 3 and 4, or root 9 and root 16, right? So this is an easy way of finding irrational number between two rational numbers. Okay, let's find two rational and two irrational numbers between root 3 and root 7. So this is the next example, root 3 and root 7. Two rational numbers between root 3 and root 7. Now see, this is going to be tricky because root 3 and root 7 are both irrationals, and you don't know which rational numbers they lie between root 3 and root 7. So you have to be very careful over here. Root 3 and root 7. We know one thing, that between these two numbers there lies root 4. You know what is root 4? Root 4 is rational. Root 4 is 2. 2 is a rational number. So root 4 is one of the rational number. We have to find two more. What about root of 4.41? Now you must be wondering, how do I know this number? I have used certain techniques where I know that 441 is a square of 21 and 4.41 is a square of 2.1. So root 3 and root 7, just see these numbers. Is 4 greater than 3, smaller than 7? Yes. Similarly 4.41 greater than 3, smaller than 7? Yes. So 4.41 being a rational number lies between root 3 and root 7. Root of 4.41 lies between root 3 and root 7, and also root of 4.41 is nothing but 2.1. Root of 4 is nothing but 2. So these are rational numbers. Now the technique is easier, so you can find one more number. Think of a 3-digit perfect square number between you say 300 and 700. 3-digit perfect square between 300 and 700. One was 400, which we wrote it as 4. One was 441. Think of something else. Yes, 625 can be one of the number. So how will you write 625? You will write it as 6.25, because you don't want the numbers to be greater than 7 or smaller than 3. You want the number between 3 and 7. That's why these decimal places will help you. Also 625 is a perfect square, so 6.25 will also be a perfect square. So root of 6.25 will be 2.5. So 2, 2.1 and 2.5 are three rational numbers between root 3 and root 7. Okay, now let's find that which are three irrational numbers between root 3 and root 7. So root 3, root 7. Okay, root 4 is rational. What about root 5? It is irrational. What about root 6? It is irrational also. What about root of 6.5? It is irrational. Why is it irrational? See, 6.25 was rational because 6.25 was a square of 2.5. But 6.50 or 650 is not a perfect square. 6.5 is not a perfect square. That's why 6.5. You can write root of 6.8, root of 5.8, root of 4.9. These are all irrationals because none of them are perfect squares. So all these numbers lie between root 3 and root 7. So inserting irrational numbers between two irrationals is simpler. You just need to know that which are perfect square and which are not. But inserting rational numbers between two irrationals is little tricky, and this method will be useful to you. You can also think of this method as this one, root 3. Can I write root 4 as 400 upon 100? Yes, I can. Now, a 3-digit perfect square greater than 400, 441 upon 100, 484 upon 100. You must know that 484 is a square of 22. Then 529 upon 100, 529 is a square of 23. Then 576 upon 100, 576 is a square of 24. Then 625 upon 100. Then 676 upon 100, right? And then comes your root 7. So how many rational numbers did we find? 1, 2, 3, 4, 5, 6 and 7 rational numbers between root 3 and root 7. Now which are these rational numbers? This is root 4, which is 2. This is root of 4.41, which is 2.1, 2.2, 2.3, 2.4, 2.5 and 2.6. These are the 7 rational numbers between root 3 and root 7. So I hope you understand that how to insert irrational numbers or rational numbers between two rational or irrational numbers, right? Now we will compare irrational numbers. Now this is a new topic. Let us compare irrationals. Okay, let's take one example. 3 root 2 and 2 root 3. Let us compare them. Now, to compare them, you must convert this simplified irrational number into a surd. It means you need to take this 3 inside the root. How to do that? So you write 2 multiplied by 3 square and you write 3 multiplied by 2 square. So whenever a number goes back into the square root, it becomes square. Whenever a number goes back into the square root, it becomes square. So this becomes 2 into 9, 18. This becomes 3 into 4, 12. Which is greater, root 18 or root 12? Of course, root 18. So this is greater and this is greater. So this is how you compare two irrational. We'll take some little difficult examples also. Let's take this one. 4th root of 8 and 6th root of 22. 4th root of 8 and 6th root of 22. So 8 raised to 1 by 4, 22 raised to 1 by 6. Right? 8 raised to 1 by 4, 22 raised to 1 by 6. Now you must take LCM of the denominator of the power, that is 4 and 6. What is the LCM of 4 and 6? The LCM of 4 and 6 is 12. So you must multiply and make this 4 into 12. So multiply numerator and denominator by 3. Here multiply the numerator and denominator by 2. So this becomes 8 raised to 3 by 12, and this becomes 22 raised to 2 by 12. Now you have to simplify this. So this becomes, if you know exponents, so you know how to simplify this. This becomes 8 raised to 3 the whole under the power of 12, or 12th root of 8 cube, and this becomes 12th root of 22 square. Now what is 8 cube? 8 cube is 512. So 12th root of 512, and here what is 22 square? 22 square is 484. So 12th root of 484. Which is bigger, 12th root of 512 or 12th root of 484? Of course 12th root of 512. So this is bigger, and of course this is bigger. So this is how you compare irrationals. Okay, so this video is over, and we are going to move on with our next topic in the next video.